Good afternoon.
Hello, sir.
All right. I'll remind you that this is an optional class. The only thing we're going to do today is review for the optional final exam. The only announcement that I think I need to talk about or a reminder to give you is those of you who are planning to make up problems, that the final day to do that for exam 4 and 5 is May 1st. That means the whole process has to be finished. You are required still to do at minimum of 2 hours of review with a tutor to do this. And when you come to me, I'm not expecting people to just wing it. I want you to be an expert at it. We're not going to give you the same problem with different numbers. I'm going to give you something like it in the general area, and I'm going to assume that you can then show me that you really know what you're doing. For example, if you had a problem with you had a mistake on a problem with substitution that involved inverse trig functions, I'm going to give you not just the same problem with different numbers, but I'll give you something that has to do with substitution and maybe an inverse trig function, but maybe something else, something that tests your knowledge of that general area. Okay, so that's exam 4 and 5. For exam 5, clearly you can't get ready for that yet because I haven't graded them yet. I'm going to do my best to grade them by Saturday morning. I had a committee meeting all day scheduled on Friday, but they canceled that. So I'm gonna be starting my grading on Friday and hopefully get it done by Saturday morning. And I'll send out an email and let you know. And there are limited appointments available because, of course, the semester ends next week. But I just added some hours here and there. I added some Saturday hours. There are hours available on Monday, Tuesday, and Wednesday. So if you're going to meet with me, it might be a little bit of a hurry. If it's, it may not be worth it to you to do that. And I'll remind you that this final, I'm assuming that all of you here are planning to take the optional final exam. That's the only thing we're going to be talking about today. That final exam will replace the final exam will replace your lowest exam grade out of the 4 or 5 grades you have. When I say 4, if you elected to drop your exam 2 grade way back when, then I'm only counting the 4. But in any case, the final exam will replace your lowest recorded exam grade if it is higher. It doesn't count for anything else. So in other words, if you take that final exam, you can't get a lower grade by taking it. You can't, ruin your average. It can only go up. So any questions on that or any of this? Okay, well, for this session, however long you'd like to have it, I'll answer questions about final exam questions, and I can tell you that the final exam questions will be chosen from previous exams. So you shouldn't see anything new on there. And I'm tending not to pick the longer questions. And I'll tell you now, I'm not going to require you to use the limit definition, for example, to take a derivative or things like that, things that are going to take a whole page. I tend to pick the smaller representative problems. If you'd like, we can go over any of those previous exam questions that you'd like. If it's an outrageous one that I know I'm not going to give you on the final, I'll let you know. But for the most part, they're all fair game. So it's up to you. Let me know what you want to talk about.
How many questions are in the exam?
I think there are 25. You have 2 hours.
And it's optional. So if like, for
something
example,
around there. It's optional.
yeah, and like for example, if I get like very low grade, it's not gonna hurt me.
Like I said, it won't. You can't get a lower grade. It's not going to can't hurt you. It can
Okay.
only make your grade get higher.
Yep.
So you can wing it. I mean, this is one of the ones it's a risk-free exam. If you already have an A by the time I haven't graded exam 5, of course, so you can't tell. But if you get an A after exam 5, I don't know if I would bother taking the final exam. It's not going to help you. If you get a B, if you're on the borderline, you may want to decide to do that. If you're on any of the borderline between a B or an A or a C or a B, it could potentially help you. And you can look at the details of what you'd have to get by going into the grade book on Canvas and replacing grades. You can do that, like put in grades and just replace the lowest with whatever you think you might get on the final and see how that works.
I have a problem that I want to talk about.
Okay.
I'm not sure. So it's from exam 2, which I took in testing center, so I don't have access. I think in exam 2 there was like a graph question.
Well, let me open exam 2 and see what it looks like. And it was a question where you had to create a graph, or
Yes. It was like the fully written question. There wasn't any inputs in the exam.
I'm going to share my screen and show you exam 2. Here's
yeah, this one.
This one. So you want to sketch a graph of the derivative of the function. Okay. All right, we can go over that. Let me see if I can make one up here. All right, so the axis is x, here's f of x. And let's say we have a function that looks like this. All right, so this is the function f of x. We could be asked to draw a derivative, sketch a derivative. And when I say sketch, it of course does not have to be exact, but there are certain things that I would look for. I want to know where it's positive, where it's negative, and where it's 0, basics like that. So I would ask myself, looking at this function here, I'm starting on the left, this piece right here. I would ask myself what the derivative there looks like. And of course, to visualize the derivative, the best way I know is to visualize the tangent, a tangent to the curve at any particular point. So let's say I'm just going to pick this point, like that's a terrible tangent. Okay, so there's the tangent at a point. And you can kind of visualize it doing different things. I see that, what does that tell me about the derivative at that point? That's right. It tells me that the derivative is positive, right? The derivative is the slope of the tangent line at any point. So right there, it's positive. So when I'm drawing the sketch of the derivative function, it's going to be positive at that point. Is it getting more positive or less positive as I go towards the right? That's right. It's getting more positive, because if you go to the right and draw another little tangent line, and that's a terrible tangent line, it's getting higher and higher. As a matter of fact, it's approaching infinity. So I would say, well, and also to the left as since it's going, it looks like it's approaching like that it has a horizontal asymptote as x approaches negative infinity. It's approaching zero, but so what would the derivative there look like? Well, it would be positive. It would be getting nearer to zero the farther to the left we go, but it'll never hit zero. And as we go to the right, it gets more and more positive. So generally, it would look like this. Okay. In other words, it looks a lot like the function itself there. Okay. So let's move towards that middle piece there, that the upside down U's, the sort of thing. Well, as we're when we're near, if we're looking at what's happening as the function approaches zero from the right. Okay, so I'm going this way. I'm looking at what happens as it approaches zero. Well, what's happening to the derivative? Well, as we approach zero, the derivative is approaching. It's going to be positive. The derivative is positive because if you draw a tangent line there, that's a positive slope. So it's going to be positive. And as we get near and near to zero, that tangent line is going to get it's going to get more and more positive until it's near and infinitely positive. So it would be positive here, approaching zero somewhere around here. Okay? I say zero because we draw a tangent line at some point here. There's going to be a tangent line that's horizontal, and a horizontal slope of a horizontal line is zero. So at some point there, it's going to be zero. And then what happens? Well, if you draw tangent lines further to the right, they're going to be negative, and they're going to get more and more negative until we go to infinity. So I would say that it looks like this. And the last piece, I would start with what's happening right as x is approaching that whatever value that is with the dashed line. It's very, very positive. It's approaching positive infinity as we go to the left. So it starts out positive infinity, and it remains positive for the rest of the graph. It remains positive forever. It just gets less and less positive. So positive, something like that. I should have drawn that in red. Okay. Questions on that?
Is that all? You don't need anything, any other information?
No, that's it. That's all I need. And the things I'm going to be looking for basically is it positive when the derivative is positive? Is it negative when the derivative is negative? Is it zero approximately where it should be zero? Does it go up to infinity? Does it approach zero? Things like that. The basic shape. So this is what I would look for.
I have another problem I want to.
Okay.
If that's okay with everyone else.
Sure.
So from exam 4, there was also like a graph question. It was like A, B, something like that. I can try to find it, but.
Well, here's exam 4. And it was also a graph question.
I think it was like question 3, but yeah, let's just go through all of them. I believe, no, I believe it was 13. Try 13. No. Okay, let me just find it.
Not seeing it. Maybe it was another exam.
No, I like 4.
If you could find a number, let me know, and we'll do it.
Mhm.
Meanwhile, any other questions that if somebody can give me a number for a problem, that would be good from one of the exams.
While you're on exam 6, can we go over exam 4, can we go over question 6? I'm mixing up the numbers.
Okay, so this question here, number 6 on exam 4?
Please.
Okay, yes. All right, so we want to determine the following indefinite integral. All right, so let's go over that. Let's try this one. cosecant squared of theta plus 2 d theta. Okay. All right. Well, first of all, I would look at these two terms separately. You don't have to write them separately, but you're going to take the indefinite integral of the cosecant squared function and the constant function. So I'm just going to temporarily write them like this separately. Okay, just so I can see them. So the first one I'm looking for, now we have our, let me make a copy of our thing here. Oops. So we have our chart here. You're gonna have that on the final exam. And so you can simply look that up. The antiderivative of cosine squared. Let me see if that's actually on here. The antiderivative of cosine squared is cosecant squared is right here. And it's negative cotangent. Negative cotangent. So that part is negative cotangent. Negative cotangent theta. And then the antiderivative plus of 2 is 2 theta plus c. And there we go. Okay, so this one was
Oh.
fairly straightforward because
Yeah,
I say
I see.
straightforward because it's one of those that are supplied right on the
Mhm.
chart for you.
Okay, thank you.
Okay, sure.
Hey, Professor. So, regarding this problem, on that formula sheet on the test, it said U du. So, are you telling us we don't have to substitute and write let statements for U du of this kind of problem?
The only time you have to make a substitution is when it's necessary. In this chart, they give you all the general. They're giving you the general setup of it, and it doesn't matter whether it's U, Y, V, or C or anything. Well, I wouldn't use C, but this is just a just a letter. They're using U instead of X. If you need to do a substitution, then you should do a substitution. This gives you the general structure of the antiderivatives and the derivatives.
Professor, could we look at question 9, please?
Yes. Okay, that's the graph one you were talking about.
Yep.
Okay, yes. So let's look at this. Let me copy it. Okay, so you have to you want to carefully read the instructions. They give you a figure. They show the areas of the regions bound by the graph of the function and the x-axis, and they want you to evaluate the integral. So, the ones where it's positive here and here, the area under the curve is gonna be the same thing as the integral from that point. In other words, the one where that says 21, we're going from 0 to a. That is the integral and it's the area. You can find the area by taking the integral. Same thing with going from B to C. However, from A to B, it is beneath the x-axis. And so if we took that integral, that would be a negative number. As a matter of fact, it would be exactly the negative of the area. So if we're looking to evaluate the following the integral, we would say that this integral from, C to 0. So we're going from here backwards to here. Okay, so they got to be careful there. Of the function f of x dx. Well, the first thing I would do is I would reverse it. I would rather go from 0 to c. And we have a property of integrals that say that if we just reverse the bounds of integration, that's equal to the negative of the same integral. Okay, so that's the first thing I would do, just so I don't get confused with signs. And it does make a difference that they're telling you to go from c to 0, because that's going to give you a negative of that. Then I would break this up into the 3 areas. I would say that this first one, everything is going to be negative. The first one from 0, instead of going all the way from 0 to C, I'm going to go from 0 to A. I'm going to start with that one. So from 0 to A of the function. That's an A. Okay. And then because it's going to be beneath there, the area there, I would say that this is going to be, well, let me just write it like this, plus A to B of f of x dx, and then plus B to C. Okay. And I'm putting those brackets because I want to remind myself that this is all negative because I went backwards here. All right, so now we have the information that we need here. Let me see if I can just slide up a little bit. Okay, so we have equals, negative, and then inside the parentheses, well, this right here, this integral from 0 to a is going to be the same thing as the area. So that's simply going to be 21. If it's above, if the function is above the x-axis, it's equivalent to the integral. The next part, this one here, that's from a to b, but it's below the x-axis. So we know the area is 6, but the integral is going to be the negative of the area. So that's going to be minus 6. And the last one, this one here, is the same as the first. It's going to be the equivalent to the area. The area is going to be the same as the integral, so that's plus 13. So that's negative, what do we have? 21 plus 13 is 34, minus 6 is 28, so we have negative 28. So you just have to be, the difficulty here is just being very careful about signs and realizing that the area has a relationship to the integral, but it's not always exactly equal to the integral. It depends on whether it's above or below the x-axis. And also they threw in the little trickiness about having the the balance of integration going from right to left instead of left to right.
So on the second line, you calculating the total area of all.
The second line, no, I'm calculating the integral. The integral. Because that's what they're asking you to do. And I only know the values of the integral by you looking at the areas, the given areas, which are equivalent to they're the same thing as the integral when the area or the function is above the x-axis, and negative of the area when it's below. So you'd be careful. If they could ask the same problem and say, what is the total area or the net area? In that case, you would just add 21 plus 6 plus 13. That would give you the net area. But here they're asking you for the integral, which is not necessarily always positive and is not exactly equal to the area unless it's above the x-axis.
I think that's the most difficult question this semester.
Really? Okay. Well, yeah. I guess it is and it isn't. I mean, of course, the math is not difficult. It's just a matter of adding and negatives. What's difficult is that I guess it's revealing your knowledge of what an integral is, what it actually is. Is it the area? How do you get it? Whether it's why would it be positive? Why would it be negative? Things like that. Rather than just plugging in numbers. So yes, in that case, in that way, it would be difficult. I got some chat questions. Let me look at those. So exam 4, question 9. We did that. Okay. Question 13. Do we do that also? No. Okay. So somebody wants to do number 13. So let's look at this one on exam 4. It's kind of good to stay on exam 4 for now. That way we don't have to flip back and forth, but we can always change. All right, so here we're looking for the area of a region bounded. Let me copy the text because it's, again, the instructions are important. The area of a region bounded by this graph and the x-axis. Okay, so this again involves whether it's negative or positive, we have to know that relationship here. Because the integral is going to be exactly the same as the area wherever this function is above the x-axis, and it's going to be exactly the negative wherever it's below. This is I think they're intentionally giving you a basic function here, an easy function, so you can visualize exactly what it looks like here. So that's definitely what I would do in this case first. So this is one over x cubed. So what does that look like? Well, as zero, it's not. We have an asymptote, a vertical asymptote at zero, so it approaches infinity. Coming from the right as the x approaches zero from the right, it's getting larger and larger. And as x approaches infinity, it goes down, it approaches zero. So the function would look like basically something like this. And I'm sure the curves are not like this, but generally like that. And on the other side, it would be the same, except everything would be negative because x cubed preserves the sign of the x value. So it would look like that and approaching zero here. Okay. So always negative on the left, always to the left of zero, always positive to the right. Okay, is that okay so far? That's just the basic graph of 1 over x cubed. And we want to find the area of the region bounded. So we have our basic picture of the function. They're going from -3 to -1. So from approximately here to here. I'm just making up points, but just it's enough to see. So somebody online or in the room, tell me, what is this? We're looking for the area. Is that going to be equal to the integral, or is it going to be equal to the negative of the integral?
Equal to the negative of the integral.
Exactly. The area is going to be equal to the negative of the integral, because when we take the integral, which we have to do, from -3 to -1, it's going to give us a negative number. As a matter of fact, it's going to give us exactly the negative of the area. So we need to find the negative of the integral. And so that's how we set this up. We say that the area equals negative of the integral from -3 to -1 of 1 over x cubed dx. If you want to get rid of that negative, we could switch the bounds of integration. Doesn't matter. I have a feeling that the negative, we're going to still be playing with negatives anyway. And then we perform our magic. So this is going to be -3. I'm just rewriting it in this way, x to the -3 dx. Makes it easier for me to know what to do with that, with the power. How I use the power rule. So this then equals negative, and the antiderivative of x to the -3, we add 1 to that exponent. So we have x to the -2, and then we divide by -2. And we evaluate that from -3 to -1. The negatives here cancel out. So this equals the same thing as 1 over 2x squared evaluated from -3 to -1. All right, so this is going to be plugging in -1 first, because we go
I'm
from the upper
sorry,
bound.
I don't understand how you got the 1 over 2x squared.
Well, we had up here, we had x to the -2. So instead of leaving it as x to the -2, I wrote it in terms of positive exponent, which means that it's going to be the reciprocal. So x to the -2 is the same thing as 1 over x squared. So x to the -n is the same thing as 1 over x to the n. That's a rule of exponents. Is that okay?
So then you just add it to the 2 at the bottom.
You multiply. It's all multiplied.
Multiply.
Yes. Okay. And then I'm going to plug in my upper bound and my lower bound. So 1 over 2 times -1 squared minus 1 over 2 times -3 squared equals 1/2 minus, what is that, 9/18, 1/18, is that right? 16, 18 minus 2 is 16, 30, 38, and then 36, is that right? 26, and this goes down to 4/9. Is that right? 4/9. There we go. Questions on that?
Are we gonna have to draw the graph like you did in the first half of this section? Of this
No.
problem?
No, it's, I wouldn't be necessarily looking for that, or let me say, I wouldn't take off points if you didn't. It was just for help for me to visualize whether I'm going to be having to take the negative of the area or the positive area. I want to know, what that is, and it was drawing a picture was helpful, but not essential. All right, somebody's asking for question 17. Right, let me try 17. So here we have a definite integral from 0 to 2x over x squared plus 5 cubed dx. Okay. So here, you have to be careful, particularly on the final exam, because you're not going to necessarily know from what chapter this is. So you might be tempted to use something with an inverse trig function. Look at it very carefully. The first thing I would consider is whether it is exactly some integral that we have listed, and it's not. It's not. The second thing I would look is to see if we can rewrite it in some easy way, and there's not an easy way to rewrite it. The third thing would be substitution, and you're going to see a lot of substitution. Okay, and so this one looks like a substitution, and I can tell you right away I see this because the derivative of this, if I make this my substitution, is this. So I have my substitution and my derivative in there, and that's very promising. So I would let this substitution, I would make this substitution, let u equal x squared plus 5. So then the differential of u equals 2x dx. Do not forget to write the dx. That's part of this, because then you can make a substitution. And here is 2x dx. It's an exact substitution. Okay? That gets substituted with du. So I now would write this as du over u cubed. Okay, so the x squared plus 5 is just u, so it's u cubed. That entire, the 2x dx is du, and we're done with that. But now we have our choice, because this is a definite integral. We have those numbers. We have our choice to whether to take the integral, find the antiderivative, and then plug back in our x values, or do we want to change the bounds of integration? Any preference?
Change the bounds.
Okay. All right. So then when x equals 0, we want to know what u is going to be equal to. And to determine this, we're going to look, of course, at our substitution. So when x is 0, what is u? Look up here. When x is 0, what is u? It's 5. Okay. And when x equals 2, the upper bound of integration, what is u? It's 9. Good. So those are my new bounds of integration from 5 to 9. Okay. And I'm just going to rewrite this so I can easily see how the power rule is going to be used. U to the -3. Remember, 1 over u cubed is the same thing as u to the -3. It's just writing it with different notation. So the antiderivative of u to the -3, it's the same as the last problem. We add 1 to the exponent, u to the -2 divided by -2. And we're going to evaluate from 5 to 9. I'm going to rewrite this because, again, I don't feel as comfortable with having u to the -2 and deciding what that is. I prefer it to be a positive exponent, so I'm going to write it like this. U to the -2 is the same thing as 1 over u squared. So I'm going to write that as 1 over -2 u squared. Yeah. That's the antiderivative of u to the -3. Okay, you add 1 to the exponent, and then you divide by that new exponent. And then, of course, here we just do the same thing. We're going to plug in 1 over -2 times 9 squared minus 1 over -2 times 5 squared. And this equals, be careful of your negatives, that equals, let me do this in my head, 28 over 2025. And there's our answer. Yes. U to the -2 is the same thing as 1 over u squared. Laws of exponents. Yeah, it's just another way of writing it. And if I see, for example, 9 to the -2, that's just not as clear in my head as 1 over 9 squared. Any other exam 4 questions? So far, all the questions we've looked at are potential problems for the final. None of them are, I would not eliminate any of them. Sure. No, I have not graded exam 5 yet. No, everyone has taken exam 5, however. So I can go. Yes. Okay. Yeah, everyone's going about just. Yeah. All right. So let's look at exam 5. And I'm sorry, which question number? 13. Okay. Okay. So we have an integral. The integral is dx over x squared minus 4y plus 13. Okay, and again, with the final, you're not going to know that it's exam 5 material, therefore likely an inverse trig function. So you got to be careful. However, if you've done enough of these, you get used to seeing that if you have a trinomial like this in the denominator, that can be converted to the difference of squares. So that's how we're gonna go into this. In other words, it's going to look like a inverse trig function. Let me pull that up again. That second I pull up the trig formula. Okay, this is what I'm looking for. Okay. So looking at these, what it looked, none of them look exactly familiar, but we have to see that we can, with using completing the square, using the process of completing the square, that it could be made to look like this. So let's do that. We're going to complete the square. So we have x, let me leave this in blue. X squared minus 4 x. Did I write y there? Okay, I'm leaving a space there because that's where I'm going to add the number that's going to give us a perfect square trinomial. And we get that number by looking at the coefficient of the middle term, -4. I'm going to put that over here, -4. And we divide that by 2, and we square it. -4 divided by 2 is 2. -2. -2 squared is 4. That's the number that we're going to add here, plus 4. We can't just add a number. We also have to subtract it. Otherwise, we'd be changing the value. So if I add 4, I have to subtract 4. So what I have here now is a perfect square trinomial, which factors in this way, x minus 2 squared. It's always going to be this in here. -2, we put a -2. And then what do we say? 13 minus 4 is plus 9. So that's how I can rewrite that. And as a matter of fact, it would be better to rewrite that 9 as 3 squared. That would make it more obvious. So let's write that here. So we have dx over x minus 2 squared plus 3 squared. So now it's looking like something we can deal with, and it does look like number 19. And I'm going to make a substitution here. It's a pretty easy substitution, but I still have to do it. This is what I'm going to substitute. That's going to be my u. This is going to be my a. It may be obvious, but I'm going to write it anyway. So my a is 3. My u is x minus 2. My differential of u equals my differential of x, because the derivative of x minus 2 is just dx. So it's a pretty simple substitution, but I think it's worth it to write them all down like that. And then we can plug it in exactly into our formula. And our formula for number 19 is 1 over a, so 1 over 3, times the inverse tangent of u over a. U over a, and our a is 3, plus c. However, of course, we don't want to have u in there. We want to eventually use our x. So our final answer here would be 1/3 inverse tangent of x minus 2 over 3 plus c. I think the difficult thing here is completing the square. I mean, I'm finding that a lot of calculus students, one of the main problems is the algebra, not the calculus. But of course, you do have to know how to recognize these. The best way to recognize these and know this is the direction you're going in is do a lot of them. Do a lot of practice homework, and after a while, you just realize it. You say, "How obvious! I've done that 6 times the other day. I know that's got to be a complete the square problem. It's going to be an inverse tangent." Anything else on exam 5 while we're there?
Professor, I have a question. So, about our grades. So right now, optional exam is showing as a grade, like it. So, for example,
The
I have
final exam will replace your lowest exam grade if it's higher. If you don't take it, it's not going to count against you in any way.
okay, and then you will just like kind of remove it from our
No, I'm not going to
grading
remove
system.
it. I'm not going to remove it. No, but it will not count in any way. No
Okay.
grade will be put there. In other words, I'm not going to put a 0 there if you don't take it, and I'm not going to put a 90 there. I'm just not going to put a grade there.
Can you
Okay.
scroll up? Professor, do you mind if we do an integral problem with E?
Sure.
I believe there's plenty in exam 5.
In exam 5, anything with E. All right.
I find myself not knowing when to use ln versus E, which is why I want the practice.
Okay. All right. Well, the first one I come upon is this one here. We're asked to find the equation of the line tangent to the following curve at the particular point A, f of A. We're given f of x and we're given A. Okay. So we want to, so first of all, if I want to find out what that point is. So the point that we're looking at is A, which is 0. And then to find out f of A, I plug in 0 into this function here. So f of 0 equals 17 times e to the 0 plus 11 times 0. So, well, 11 times 0 is 0, 17, e to the 0 is 1, so it's 17. Okay, so there's our point that we have. That's the first thing I'm going to do. And I'm going to, this equation is going to look like this. Y equals the slope times x minus x1 plus y1. However we want to write that. The x1 and the y1 are these numbers here, 0 and 17. So I'm going to put those in. So y equals m times, well, m times just x because it's x minus 0, so x plus 17. Let me know if I make a mistake. And so the only thing I need to find here now is the slope. How do I find the slope? Well, the slope is the derivative at that point when x equals a. So we need the derivative. The derivative of this function is, well, 17 is a constant. The derivative of e to the x is just itself e to the x. If you can't remember that, remember that. It's got to be the easiest, one of the easiest things in math. It's itself, but it's also on the chart. Okay, and then the derivative of 11x is just 11. So that's the derivative, but we want it specifically at the point 0, 17. In other words, when x is 0. So we want to know the value of the derivative at 0, which is 17 times e to the 0 plus 11. E to the 0 is 1, so we have 17 plus 11, or 29. Is that right? 17, 28, 29. Oh, no, 28, right? 17. You got to keep an eye on me. It's 28, right? 28. Okay. And that gives us everything we need to know. I'm going to finish up the final board. So I'm looking back up here. And all I needed was the slope. So we have y equals 28x plus 17. There's my equation of the line.
So to find m, you set everything to 0?
No. What is m? M is the slope. How do we find slope? What is slope? In calculus, well, how do you find a slope? It's the derivative. The derivative is slope. And once you have that derivative, that gives you, of course, here's the derivative. That's the slope at any point x. And to find a specific number, you plug in whatever x you want to on there. Let me give you. So let me see. Our function is 17 e to the x plus 11x. All right. Well, I'm using here's Desmos, and there's the graph. We're looking for the slope of this point of this graph. Ultimately we're looking for the equation of the tangent line, and the line is going to be tangent at 0 right here where x is 0, wherever that is. It's going to be 17. I happen to know right there, and so it's going to be a pretty steep line. But if I want to know the slope at that point, I have to take the derivative and plug in 0. Plug in x equals 0. You were saying, does it have to be set to 0? It just happens that this problem is asking you. It gives you a point of 0. They didn't have to. They could have said, when x is 5, and then it would have been a different, then you just plug in x is 5. 0 isn't a magic number in this case. It's just, this problem happened to say a equals 0. you have a function that looks like this, and you're told to find the equation of the tangent line at this point right there. Well, I need to know a point. So we have a point. Y equals slope times X. Let's say that this is the point 3, 5 for some reason. So X minus 3 plus 5. The only thing I need now is the slope of that line. We find that by taking the derivative of the function, okay, and then plugging in the point 3 right there. And that gives us the slope. Okay, so that's the main thing you should know about derivative is that gives you it's the slope of the tangent line at a point. Other questions? Beautiful day out there. It's going to get warmer and warmer. Okay, well, I guess we will wish you luck, and let me know if you have any questions. If you're making up a problem, some exam, please make sure you know what you're doing and you're ready to go. And that's it.
So really quick, if we have time, can we do question 9 from exam 2?
Oh, I thought we were finished.
Sorry, I was in the bathroom and I came back and I realized
Okay,
that I still
so
only had
exam 2, number 9.
Yes, thank you.
Okay.
I'm
Yeah,
sorry.
sure. That's all right. Many people have to go to the bathroom sometimes. Exam 2, number 5. Okay. Okay, so we have a function f of whatever reason it's using w equals 6w to the 5th power minus 7w to the 3rd power over 5w cubed. And we're looking for the derivative here. Well, we have a couple of things we could do. One, we could just keep this function as is and use the quotient rule. But I definitely don't want to do that because this can be easily simplified, this function, and then the derivative will be a lot easier. So I'm just going to simplify this. This is going to be 6w to the 5th over 5w to the 3rd minus 7w to the 3rd over 5w to the 3rd. which simplifies to 6/5 W squared minus 7/5. And
Okay,
then
and
for
I
the
wasn't showing your screen. I just didn't want to interrupt you.
oh, okay, yeah, sorry about that.
Yeah,
I was already
it's
packing, ready to go
okay.
home, I'm sorry. All right, there we are. There's the function simplified. The derivative is, well, I'm going to take the using the power rule over on that simplified version, is going to be 12/5 W. That's it, because the derivative of negative 7/5 is just 0. And there we go. So the first thing you should always do is to see if you can simplify, rewrite the function and put it in a simpler form. We could have used the quotient rule and we would have gotten the same number. It just would have been a lot more difficult, I think. Certainly several more steps. And the more steps you have, of course, the more likelihood that you'll make an error. So,
Okay, thank you. Have a good day.
you too. Any other questions from anybody? Okay, then good luck. I'll look to see your grades for exam 5 by probably Saturday at noon or so. Okay, and have a great summer. Bye-bye.